This is the next section, just basically exploring data, and we'll learn a little bit more about just what variables are and the importance of exploratory analysis, the importance of setting goals, documenting your data, communication, all of those things. So I just thought I'd put a couple of notes in here. This doesn't really seem applicable to or that important when we're dealing with statistics, when I talk about project leadership and communication. But I find that, you know, I think we all work for organizations where, you know, we are likely to be working on a project together and perhaps like working to either collect data or analyze data or carry out tasks where we need to be able to work together and just be good at our communication. And a lot of times that means just as a good leader, being a good listener, creating these timelines, goals, and standards. So just being clear about what's expected from, you know, either your data collection, analysis project, being consistent and clearly documenting your work and producing timely updates. So I think that that's just a really important part of being a good team member. And if things aren't clear about what your goals are for a project or what you're trying to, you know, what you're trying to achieve, then just asking these clarifying questions. I mean, a lot of you are probably much more experienced and knowledgeable about this than I am, but I've just been in my work as a statistician in moving from education. I've just been noticing how important these are for my success of just being really organized, making these documents and presentations that are readable and approachable to all team members who might have different strengths in terms of their ability to understand data and graphs and whatnot. And one of the things that I've learned the most about in my work in moving into research is when I'm excited about learning new skills or methods or job tasks, that it just seems to open up new worlds for me and my team. And it's so much more fun when, you know, you're excited to learn new techniques and have that ability to be able to just push your skills to the next level. So just being excited about trying those new things, and then just making the effort to produce results or complete tasks that might be novel or add unexpected value to a project. So those are just kind of a little bit beside the point of our task, but I just got excited about sharing the slides with you. Okay, but data cleaning and organizing. So often one of the most important things that you are going to be doing is organizing and cleaning your data. And it's really counterintuitive. When I work with different people who bring me their data, they're always kind of quite surprised at how much time we actually spend just organizing their data in a way so that it's consumable. And so just putting it in the right format so that our software can be as useful as possible to us, making sure that we understand what each variable represents. And so one thing that really helps with that is by making what we call a data dictionary. So, you know, so for example, here's an example of a data dictionary where we have the variable name, we have, you know, let's say I'm looking at the heights of all these individuals, whether or not they are smokers, whether or not they develop dementia in a study, their particulate matter that they're exposed to. I do some work with air pollution. So these are just examples of possible variables that you might have for your data set. But then this just allows you or anyone else who comes to your data later to say, well, what does that variable PM 2.5 really mean? Well, then you could go to the data dictionary and it would be right there. So anytime I'm looking for working with a new set of data, I my first step is always to clean it so that I know what all the categories mean, get it in a format that I want. And then I create this data dictionary so that me and my future self, who forgets in a week, can remember what all of those variables mean. And then anyone else that I'm working with or anyone else who's going to access the data later will know what they mean as well. So I really like creating those data dictionaries. I will say just a little bit about statistical software briefly. I'm not going to make any assumptions about software or talk anything about software today. But I did want to just outline a couple of, oh, my numbers got off, sorry about that. I did want to outline just a couple of softwares that are out there that I think are really nice and approachable in different ways, and they have different they have different pros and cons depending on what you're doing. So if you are, I noticed that some of you are working in R, some of you aren't working in a statistical software, and that's completely fine. But if you're thinking about starting a new software, some things you might want to ask yourself are, what is currently being used by coworkers or other people who you might be interacting with? Because this is a big deal when you're trying to learn more and work together. If you're working in two separate platforms, that can be kind of a tricky thing if you're trying to work together a lot. So that might weigh in on your decision about what software to use. What will allow you to best communicate statistical ideas to your audience? And what I mean here is, you know, if you're going to spend a lot of time learning about how to program in R or Stata, that is great. But if you are just really looking for a quick and dirty tool that can just give you some graphs and statistics, you know, you might not want to dive into into those programming languages that have a little bit of a steeper learning curve. Not to say, I mean, they're still great, but you just want to think about what your goals are. So if you're just looking for those a more quick and dirty tool that has more of like the drop down menu, you could use something like SPSS, which it's viable. It is a little bit cost prohibitive, but it could be that your work would cover that. StatCrunch is this online software that I really like. It was developed through actually a textbook that I used to use in a course, but it's just an online point and click, basically menu-based system. But it has, I mean, everything you would likely need for analysis. And so I really like that if you're just looking into getting started with some basic analyses. R is phenomenal. This first one here, this is what I use. It has a little bit of a steep learning curve, but it's all free. There are lots of people who contribute packages and a lot of documentation out there on anything you would want to do. So if you're interested in trying to learn that, and there are also what they call GUIs that have the drop-down menu type framework there within R that can also be helpful as well. And then there's a few other here that I've listed. But if anyone has any questions, were there any questions in the chat about those, Emily? I didn't see any come through. Okay, great. So yeah, I mean, I think that it's worth thinking about. And you can also make graphs and charts and tables in Excel. Some of their graphs have been known to be a little bit misleading, but they're still quite useful. And there's, you know, some that's certainly an option as well using Excel. Okay. Let's see here. So the terminology, just a couple of definitions for you as we get started. So when we refer to data, It's actually plural. So when we say data, a lot of people use it as a singular term, but the term data is actually plural. So we say data are any collection of numbers, characters, images, or other items which describe items of interest. And then variables are just these quantities or characteristics recorded on each object. So variable, like a bunch of variables put together for a single data set would be data. And then statistics is used in two different ways. So statistics as a field is a way of reasoning along with a collection of tools and methods designed to help us better understand the world. And then statistics are, when we're thinking of them as a methodology, they're numerical calculations and summaries made on one or more variables, such as the mean, the proportion, sample standard deviation. Let's see, I must be replicating things. I have sample proportion. I really love proportions, so I put them in there twice. They're my favorite. Okay, so let's look at some real data. So I'm starting to work on a project where we're looking at birth outcomes. And so I was trying to figure out how could I get access to birth outcomes in Montana. So there's a project where we're going to be able to look at some data that actually come from health records, but there's also these freely available data to the public through this Montana Public Health Information System, which maybe you all already know about. But I just put it up here so that you could see what it looks like. And right here, there's a little section that says data queries. And it could be that if I had a little bit more finesse with SQL, I could come up with these queries and be able to get a big data set all together. But I went through and manually clicked on each year and had to combine a bunch of different things to get a large time series of data. But I'll show you what I did. I clicked through and I ended up grabbing all the different births by county from 2019. 2019 is the earliest year that's available right now, all the way back to, I believe, 2005. And so I'm just showing you what the data looked like when I downloaded them. And so I ended up having to download year by year. It took me quite a while to do it, but I now have this data set that I put together of year by year birth counts for every single county. And so so when I'm talking about organizing and tidying your data, I'll kind of talk to you about what I mean there. So the next thing that I wanted to do, I wanted to look at deaths as well. And I also wanted to look at overall population numbers because, you know, Flathead County has, you know, in the thousands of births, whereas say Beaverhead, or let's say Blaine County has nearly 100 births. But if I want to look at how those are changing over time or make them comparable, I want to also know the overall population of those counties so that I can better understand them relative to the county population. So I also went back and then got some other variables from the same Montana IBIS data, or the Montana IBIS website. And these are, so this is just an example. Then I decided to organize them a little bit different. So notice now, because then I had 3 different variables that I was grabbing, and I'll explain to you what these mean in just a minute. But notice now that I instead made year as I combined them all into one column. So it goes 2019, 2018, all the way down to 2005. And I've repeated this Beaverhead County. So up here, each county was just one row. And then on the next slide, I have, the county is still the row, but each year is replicated within the row. And so this is what I mean by reorganizing your data. So this is what we would call, this format is what we would call wide format. And this is what, and it seems kind of inconsequential that we don't care, we shouldn't care how these are organized. But it turns out that this is called long format. Turns out that long format is a much more efficient and easier way to analyze data. So whenever possible, I try to keep my data in this long format if I can. So then so these are TLL it's an interesting variable. It's total, it's the years of potential life loss. So these are data on deaths. So these are years of total potential life lost for that county in 2019. The TPL is the total population for that county. And then TYPLL is the total years of potential life lost per 100,000 people. So then it's scaled onto a scale that is comparable across counties. Okay, so putting all of this together, I also wanted to be able to compare these different statistics that I'm getting from Montana IBIS relative to these common division lines that we use. And so these are, we'll look at these numbered areas throughout this section. So I just want to show you where these numbers are coming from, and I'll keep going back to them. But when I talk about area 1, 2, 3, 4, and 5, this is where they're coming from. And it's just dividing the state into some different sections so that we can just make some comparisons. Okay, so my final product, so then my data organization, I ended up taking the birth data, putting it into long form, so then I can merge them all together. So now I have this really long data set where every county shows up from 2005 to 2019, and it's for all 56 counties in the state. And so then and then notice that the region is replicated as well. And that might seem inefficient, but it ends up being actually quite helpful. So even though, it seems like I'm just keep entering the same number, it's fine. And it ends up being a better way to organize our data. So this is in what they call tidy form. That's like a term that they use a lot in R, that we like our data to be tidy. Okay, so now we have this data set that we're going to start looking at, and looking at some graphical outcomes for them. So for our data, we just want to ask ourselves some of these questions here. What are the data? What are the variables? And are they categorical, quantitative, and so on? So the data themselves are, so the county is a variable. It's varying from row to row. The year is a variable. Births, the number of births per year, that's a variable. And then each of these is a variable as well. Okay, so a variable is anything that has the ability to change from unit to unit. So all of these are considered to be variables. Okay, county is really an identifying variable. It's a unique identifier basically in this data set. And the next thing that I asked was, are these variables quantitative or categorical? So this is going to be important in us deciding on what types of summary statistics and graphical analyses to use. So we want to think about what is graphical or what is categorical, what is quantitative. And so when I think about quantitative, it just, we define it as anything where numerical comparisons make sense. Okay, so for example, if I say that Beaverhead County had 96 births and Gallatin County had 1,072 births, that numerical comparison makes sense, okay? If I have a county from region 4, and I say, but then this other county is in region 3, well, that doesn't really make sense in terms of a numerical comparison, even though they are numbers, right? It's not like I would say, well, 4 is greater than 3 in terms of something that's meaningful. So a numerical comparison does not make sense for the region variable. So I would say that region is a categorical variable, meaning that it's categorized. It doesn't really have a meaningful numerical comparison that can be made between the counties. But all of these other variables here are quantitative, okay? They're measuring something about the county. And then year is a little bit of a, it's certainly still a quantity. It's still numerical as well. But it has a little bit, it's a time variable. So it kind of has this in between distinction. And then of course, county would be categorical, categorical variable. Okay, so how are we going to, now that we have this data that we've downloaded from Montana IBIS, how are we going to start to get our hands dirty and learn a little bit more about what these numbers look like, how they compare across the state? Okay, so these are, you know, a bunch of different examples of graphs, and you see them all over, these different types of graphs that we can make. And I'm going to talk a little bit more about you know, how to choose the graphs, but I'm just going to start by introducing you to a couple of basic plots. And this is, I apologize, this slide is so busy. And I know that this is a little bit of a busy slide, but I think that it's really nice to just see everything broken down fairly, just like succinctly. So basically, once you decide what type of variable you're working with, then that will help you decide what types of displays you can make. So if you know you're dealing with a categorical variable, then you really only have a couple of options. You can make a pie chart, a bar chart. You can make what are called segmented or side-by-side bar charts. And there are a few other options, but this is really the main thing that people use, pie charts and bar charts. Quantitative data, you have a little bit more options. And I've listed them here, and we'll go through quite a few of them as well. Then we also have spatial data, which are my favorite to work with. They're just, I love making maps. But spatial data are just like they sound. They are, you know, usually numeric, sometimes categorical, but they are specific to a location. So we have lots and lots of location data every time we look at maps of COVID rates, looking at air pollution maps. Those are all spatial data. And there are lots of different types of them as well. And you can take an entire year's worth of statistics just focused on spatial analysis. Similarly, time series data, they're just like they sound. They're also variables that are recorded with respect to time. Okay, and there are, you know, just so many examples. We could look at air pollution over time, how it's varying. So you could have spatial temporal data if you're looking both at the location and the time. You could be looking at health outcomes over time. There's lots of different options there. But the most important things to ask yourself are, is my graph simple and easy to read? Does everything in my graph have a purpose? So we don't want like a lot of fluffy, you want to be able to make your graph memorable and to catch an eye, but you also don't want it to be so distracting that we can't get the overall picture of what's happening in our graph. It's really important that our scales and the axes are correctly labeled and represented. So this is a really common thing that happens. These misleading graphs will often have incorrectly spaced axes. And one thing you can do to prevent that is to make sure to use a well-designed statistical software so that doesn't happen. And then making sure that everything is properly labeled so that your reader understands what is being presented, which is really important. Okay, so first thing, visualizing categorical variables. Okay, so again, remember that we have these counties that are broken up into these 5 areas. So if we think of all 56 counties in our data set, what I did is I just took each county and I counted, well, how many counties are in area 5? And then I plotted that with a bar, right? So it looks like there were, it looks like there are 7 counties in area 5. Let's see if that's right. 1, 2, 3, 4, 5, 6, 7. And that is 12.5%. So I've labeled the percentage here as well, just for ease of understanding. So we know that there are 12.5% out of all the counties in the state live in area 5. Okay, and similarly, right, we have 30.36% of all the counties live in area 1. But then if I went and looked at population, that might look a lot different, right, relative to just the number of counties. So this is a bar graph, and this is a pie chart, the same exact data, but just represented in different ways, okay? So notice that, you know, the pie chart is quite pretty, and a lot of people love pie charts, but notice that it's a little bit harder. I mean, you can see that this 12.5% is smaller just in terms of looking at the shape, but it's just quite a bit easier to discern the difference in the bar heights as it is relative to trying to figure out the difference in the pie sections. So in general, even though pie charts are quite pretty and they're fun, I tend to go toward bar charts just because they're so much easier for the eye to be able to detect small differences in those heights. All right, so each of these graphs below represents the same data. So this is just to get you thinking about properly representing your data. And I'll just ask you which of these, and you can just enter it into your chat if you want to take a stab. But there are actually 2 graphs that are pretty decent in my perspective, and then 2 graphs that could use some work from my perspective. So why don't you just tell me which 2 graphs are misleading? Okay, so we've got a vote for D. I'll hold on for another minute or so and see if anyone else wants to chime in. C and D. C. And we have a vote for A and C as well. Okay, great. Thank you for participating. I appreciate that. Yeah, so it seemed no one mentioned B, so B is a good one. A is still, it does actually represent the data just fine, but you're right, those people who chose A, the scale of, you know, the range of those percentages goes from 0 to 50%. And it really kind of is a little bit misleading in terms of it shows the counties being a lot closer, or excuse me, those areas being a lot closer in terms of percentages than they really are. And thankfully we do have the actual percentages written there. But just in terms of looking at it with the eye, it's just not as representative of the differences that we see in B. So I would agree that A is not as ideal as B. C, most of you put down C. And notice that C actually starts, it doesn't even start at 0. It starts at around 7. So that can be really misleading. And so we always want our scales to go from 0 all the way up to, you know, basically the maximum, maybe a little bit higher than the maximum. But that can tend to be really misleading. And it just makes, say, area 1 look vastly larger than area 5 when it's really not that vast of a difference as it shows in graph C. D, a couple of you said D is misleading, and I would say that I can understand where you're coming from, because then these categories are getting rearranged, and that can be a little bit, if you're trying to figure out how much to focus on, that can be a little bit misleading when we have these regions that are already numerically organized. I will say that I actually do like organizing categories from least frequent to most frequent in terms of my bar charts, because they just seem easier to like figure out how they're just some of the differences just by eye. But I also recognize that these numbers being jumbled can also be hard to follow as well. So I think you could go either way with D, but thanks for participating. In general, again, just making sure that everything is clearly labeled. Remember that bar charts, we'll talk about histograms later, bar charts have a space in between them to signify that they're actually categories and that there aren't these continuous variables, which we'll talk about soon. But just remember, bar charts should always have that space in between the bars, which again will be the case if you use the, I think we've covered those, but just again, just trying to always keep in mind to be clear that graph area should always be proportional to the frequency, and everything should be labeled accordingly. Okay. So now we get to, so we just looked at a couple of categorical displays, and now we're moving on to displays for quantitative data. And we're going to use this data set from Montana IBIS for to motivate some of these displays. So the first one, and one of my absolute favorites, is just this super simple dot plot. And all it is you're taking a dot and putting it on the number line to represent whatever county it is. So for example, if we're looking at county population size, and I put a dot for each county relative to what the population size is. And these are what they call jittered, so that we can, so the height of these dots does not matter at all. It's just on the number line. And they're just jittered so that we can see them, because there's a lot of clustering down here. So the height doesn't matter. It's just the position on the number line here. So we see basically that, you know, from all of our counties, most counties are less than 25,000 people in population size. And then we have a handful of much larger counties as well. But there's a large clustering of these lower population counties, which, you know, is certainly not surprising. Then we can look at births, and these are interesting. So these are the births on down here in yellow, the birth numbers. And this is in just 2019. So remember, I downloaded this whole time series data, but I'm just focusing, I just took a little slice and I'm just focusing on 2019 here. And then I thought, well, but that doesn't tell me a lot, because I don't know how many people are in that county, right? And so maybe that's not the best variable to look at. So I used the population size within each county to get the births per 100,000 people. And then I was able to get this variable. And so then it just shows you how those births are distributed throughout the state. And we'll look at some techniques for labeling those counties as well here soon. But so those are dot plots, and they're extremely useful for just, I can't tell you how often I work data and groups where we, myself included, forget to just look at pictures of our data, and they can be the most revealing part of our analysis. Just understanding what they look like and how they're distributed. We can see, we can automatically very quickly identify any unusual points or maybe typos in data entry by just looking at our data. It's the most, in my opinion, the most important, aside from data cleaning, the most important part of your analysis is just spending, a couple of hours or a day or two just exploring and getting familiar with what your data look like. And it will serve you lots of rewards in the future if you, and lots of headaches, prevent lots of headaches by doing that ahead of time. Okay, so dot plots. Then we move to histograms, and histograms also display quantitative data. And notice that the bars are right next to each other. And I'm just gonna really quickly look at this. Just give me 1 second. Okay, thank you. Sorry to interrupt. Okay, so histograms, they are just like bar charts in terms of how we read them, but they're displaying quantitative variables. And so notice that these bars are touching, and so there's no actual clear separation here. We're just binning the data so that we can visualize them, but there's not actually actual binning going on within the variables. So for example, this is showing me that there were, in this bar, there are approximately 36 counties that had between that had between 0 and 100 birds. So 36 counties, see the bar height right there? 36 counties that have between 0 and 100 birds. And then there were about 9 counties that had between 100 and 200 birds. And then we have this one county way up here that had nearly 2,000 birds. So does that make sense to everybody? Is that okay? Feel free to let me know. These are very commonly used graphical displays, but I think that they're also the most commonly misinterpreted as well. So please let me know if you want me to go dig a little bit deeper there. And remember that each height is representing a county. So we're just kind of binning these counties together to look at the distribution. And if we look at this number of birds histogram and go back to this, you can kind of see it makes sense. There's this big cluster down here, which would be that big tall bar. Okay, and then there are these smaller bars here because there's less frequency. Okay, so this is where that huge bin went right here, and then smaller bins down to the right as the birds get larger because there's fewer counties in those higher birth numbers. So then we have county population as well, and again, we have a very similar distribution, which makes sense. Because we would expect these birth numbers to be similar to the county population numbers in terms of distribution. And then when we go and look at the births per 100,000, then we see that we have this, we can go back and look at this distribution here, right? And now we see where these bars would look like they would be more evenly distributed and what we would start to call a little bit more normally distributed. We have still have a little bit of a peak here, but we have a little bit more even distribution as well. So are there any questions about histograms? Okay, great. Okay, so now scatter plots are some of my absolute favorite. They allow us to look at the relationship between two quantitative variables. So if we look at, for example, we look at our population size in 2019, and then we also look at the number of births in 2019, this one dot represents a county that has approximately 150,000, a little less than 150,000 in that county, and then a little bit less than 2,000 births. So it's allowing us to look at two variables in just one, and just with one little dot, it's showing us the two separate variables at the same time. So it's very efficient. And it allows us to look at the relationship between the two variables, not just the independent, the individual distributions. So those are two separate things. And you can see, and a lot of times we'll look for what we would call outliers. So maybe there would be, I actually thought there might be a county that maybe had, higher population, but maybe either higher number of births or lower amount of births than what is commonly seen. But it looks to me, just based on these data, that it looks like there's just this, a basic, strong, positive, fairly linear association between population size and births, that in general, these counties are following the same trend. So then we can add in a third variable and add in the name, the county name, if we want to. So right here, this one that's way up in the top right is Yellowstone County. Then we have Gallatin and Missoula County, Flathead County, Cascade, Lewis and Clark. So I just chose to label a few, because if I label too many, then all of the words get jumbled down here. But that can be a really nice way to add a little bit more character and information into your graphs, is to label a few of those points. Okay, so just a reminder of these hospital regions. And now if I look at a scatter plot of births per 100,000 people on the x-axis, and then the years lost per 100,000, I get a scatter plot that's pretty much what we would call random scatter. There does not appear to be a relationship between the birth rate and the years lost per 100,000 people. So there doesn't appear to be a relationship there. And then we also look at their hospital region. So this is a labeled scatter plot. So I have three variables in here right now: the birth rate, the years lost, and then the hospital region is color coded here. Okay, and so we can see, a lot of times labeled scatter plots will reveal some trend that, say, maybe if you're looking at a scatter plot and then maybe you separate by gender, you might notice that males are behaving differently than females, or you separate by geographic region and you might notice some differences.
There was a question in the chat, just yeah. Is the birth data from the mother's county of residence or where the birth occurred?
Oh, that's a great question. I'll have to look back at their description from Montana IBIS. I'm pretty sure it's from their county of residence. I will have to look back. I'm sorry I don't have that right in front of me, but I'm pretty sure it's the county of residence, because it's yes, I'm pretty sure that that's the case. Yeah,
sorry, no problem. I'm the one that asked that question.
Yeah.
The reason I asked is the IBIS data is almost surely the mother's county of residence. The reason I ask is because if you redid your analysis with county where the birth occurred, it would look so much different. And I use that sometimes just to show how many births occur outside, because Montana is such a rural state, how many births occur outside of the county, the mother's county of residence. So like Billings, Yellowstone, Cascade, Gallatin counties also have, the bulk of the births because people from surrounding counties go to the hospitals there.
Oh, thank you for that. Yeah, it's really interesting. Especially with, there's so many issues with rurality that I think are really important to consider that sometimes fall through the cracks. So I appreciate you mentioning that. I'm writing that down because these types of data are new to me, the birth data, and so there's a lot of things I still have to read about. But thank you. Good point. Okay, let's see here. Any other questions or comments? Great. So within the labeled scatter plot, sometimes we'll see some trends and sometimes we won't. And, in here, we're not seeing any relationship either between these two variables. And I'm not going to talk about the correlation coefficient, but, the correlation coefficient is a way to measure the strength of a linear association between two variables. So, for example, the correlation coefficient here, although because of these spaced out values, we might not want to use it, but we would have a strong linear association here and that would be indicated by the correlation coefficient, whereas there would be almost no correlation here because there's no linear association between those two variables. Okay, so now I just want to talk a little bit about some summary statistics. And I'm sure that you all use a lot of summary statistics, whether you realize it or not, in day to day. The mean or average is the most commonly used statistic that we have. But I would also encourage you to use what we call percentiles, or the 5-number summary, which breaks up our distribution into quartiles. And those can be really helpful, especially with data that have outliers that are going to largely affect the mean. And so I would encourage you to also use the median and these quartiles in addition or in place of the mean, just because the mean is sensitive to those outliers. So let's just take a look. The births per 100,000. These are the same data for 2019, and I'm looking here at this distribution across all the counties. And the median is where our data are split exactly in half. So the median for births per 100,000 is 1,081. So 1,081 would be about right here. And it's, so that makes sense. About half of the counties would be less than or equal to that, and half the counties will be greater than or equal to that in terms of their births per 100,000. Okay, then the 25th percentile tells us that at 882, which is about right here, is where there's 25% of the counties have a birth at 882 or less per 100,000. And similarly, the 75th percentile is at 1392, which is about right here. And that says that 75% of counties have birth rates of 1392 or less. And so the min, the 25th percentile, the median, the 75th percentile, and the maximum, those 5 numbers put together are what we call the 5-number summary. And they're just a really nice set of summary statistics for you to get in the habit of always presenting. They tell you so much about your data in general. And you can also then also give the mean and standard deviation as well if you want to, especially when people aren't as familiar with the mean and the median, or excuse me, the median and the quartiles. But I will show you this, this one right here. So the population median is 6,553. The population mean is 17,937. Look at how different those are. The mean is almost 18,000 and the median is 6,500. And this is why I'm saying I believe that it's important for you to consider using the median, especially when you have outliers, because the mean can be extremely misleading when you have those large outliers in your data. Okay, so it's because, you know, we have these just a handful of counties that have these really big population numbers. And then when you take the mean, which is calculated by adding up all those values and then dividing by 56 counties, then that mean gets skewed or it gets pulled up much further than the median. So that's why we just want to be really cautious about using the mean. Not to say it's still a fine measure, but we just need to be cautious about it. It happened as well in the births. We had the 69 was the median and the 201 was the mean. Any questions about that in terms of those summary statistics? Just also keep in mind the standard deviation is based on the mean, so it's also very sensitive to those outliers. So a measure of spread you can use instead of standard deviation is just the interquartile range. You can take the 75th percentile and subtract the 25th percentile to get a different measure of spread if you're looking for that. Okay, great. All right, so it looks like, so I just want to show you a couple of more graphs and then we'll take a little bit of a coffee break here. So now I created these dot plots. I thought this was kind of a fun plot. So we look at the birth counts again, but now we separate them by Montana hospital region. And there's just a lot going on here in terms of comparing, if we're looking at comparing distributions, which a lot of times we like to do in statistics. So we like to think about, well, what's the overall difference in central tendency? So in ways that we can do that is by comparing the medians. We could compare the medians between regions 1 through 5. But then we also want to compare the overall variability. So look at region 3, ranging, you know, it has counties that have a lot of fluctuation in their birth counts versus say region 5 that has very little fluctuation and region 4 that has very little fluctuation as well. So those are just things to consider when you're making these comparisons. And then this region 2 tends to have pretty high number of births. Oh, I have a label error there, but births per 100,000. But then there's this outlier down here as well. So this is a dot plot by a categorical variable. Another plot that we can look at is box plots. And box plots just display the 5-number summary that we talked about, the minimum, the first quartile, the median, the third quartile, and the maximum. They display those 5 numbers, and they're really useful when we're trying to compare a lot of different groups, so that to our eye, it's easy to compare them. So again, these are those 5-number summaries, and each of these 5 numbers corresponds to those lines that I just showed you, with the exception of this number 2, and there's a special rule that our software uses to decide that this is an outlier, so that we're able to detect, oh, there is an unusual point there. So this box plot is, if you can look at them right next to each other, these are showing the exact same data. And so I feel like box plots are extremely useful, but in general, I think they're often misinterpreted when we don't understand that these dots are what is making this box plot. And that there could be only 5 points representing a box plot, or there could be thousands. And it's really hard to know because it's just based on those quartiles unless you put a sample size or you know what you're dealing with. So just be careful with them. But they're extremely useful for comparing a lot of different groups simultaneously. So those side-by-side box plots are a great technique for that.